A designer designed 5 different tops, 4 different pants, and 6 different jackets. How many different outfits consisting of 1 top, 1 pair of pants, and 1 jacket can the model possibly wear? One way to approach this is by using a tree diagram. If we were going to do this, I might call the tops T sub 1 through T sub 5, since there are 5 of them. The pants could be P sub 1 through P sub 4, since there are 4 of those. And the jacket could be J sub 1 through J sub 6, because there are 6 of those. And then you could just do a tree diagram. It's going to be pretty large, and it should motivate us to try to do it differently. But I want to at least throw that out there first. So for instance, if you say the designer is going to use top 1 for sure, and then look at what other variations there could be, there would still be 4 choices of pants even after the designer has decided to use top 1. And then once the designer has decided to use top 1, then if he chooses pants 1, there are still 6 different choices of jackets. If he chooses pants 2, there are still 6 different choices of jackets. If he chooses pants 3, there are still 6 different choices of jackets. And if he chooses pants 4, there are still 6 different choices of jackets. But this is only assuming that the designer went with top 1. There are 24 of those. 6 times 4 is 24. But there's nothing to say that the designer has to choose top 1. So 24 is just the number of choices the designer has, assuming he goes with top 1. But because he could choose top 2 or top 3 or 4 or 5, then you have to consider those possibilities. So suppose the designer decided to use top 2 instead of top 1. That would generate 24 more outfits. If he decided to use top 3 instead of top 2, that would include another 24 outfits. Had he chosen to use top 4, that generates yet another 24 outfits. And finally, if he decides to use top 5, that generates yet again another 24 outfits. So if you have 24 outfits for T1 and for T2 and for T3 and for T4 and for T5, that means there are really 120 different possible outfits. You can see why I didn't want to draw that as one single tree diagram. It would just be too much to even fit on the screen. But you could break it up into subparts and look at it that way. Even then, that's a very long, complicated process trying to use a tree diagram. But it will give you the answer of 120 different outfits. But because we've already talked about the fundamental counting principle from the next section, we could actually use that to make this problem a lot easier to solve. So that's what I suggest in a problem like this, that we actually use the fundamental counting principle just to make the problem much more manageable. Remember, the fundamental counting principle that we covered already says that a task composed of a series of subtasks in which the first subtask can be performed in A ways, the second subtask in B ways, the third subtask in C ways, and so on, can be done by multiplying the number of ways each of those subtasks can be done all together. And that's what I would suggest here. You're going to be choosing a top, a pair of pants, and a jacket. So the fundamental counting principle says if you can count the number of ways to choose a top, count the number of ways to choose your pair of pants, and count the number of ways to choose a jacket, you can multiply them all together to get the total number of possible outfits. So that's much easier than doing the tree diagram. I think you'd agree. There are 5 tops to choose from. There are 4 pairs of pants that can be chosen, and there are 6 jackets. 5 times 4 times 6 is 120. You get exactly the same answer that the tree diagram method gave me, but much more efficiently and much faster.